Hello, and welcome to section 4.4 on concavity and curve sketching. And in this section, we're going to start out with some basic information about the second derivative and what effect that's going to have on a function's behavior. So in the last section, 4.3, we had looked at the first derivative test and saw how the first derivative can affect a function, showing us where the function is increasing and where the function is decreasing, helps us find local maximums and minimums. Now we're going to do a similar thing with the second derivative. So first off the bat here, what the second derivative describes is how the first derivative is changing. Okay. And that hopefully makes sense because it has the same relationship to the first derivative as the first derivative has to the original function. So like the first derivative is telling us how the original function is changing, all right, change of the original function, like a dy dx type of thing. The second derivative is looking at changes in the first derivative. So you could also think of this, since the first derivative refers to slopes of tangent lines to the original function, the second derivative is going to tell us how those slopes are changing. Okay, so let's look at this here. If we have a second derivative that is greater than 0, okay, so think back for just a second to the last section. In 4.3, we saw if f prime of x was positive, then the original function was increasing. And so we're going to take that same relationship now and map it to the second derivative here. So if f double prime of x is greater than 0, that's going to tell us that f prime of x is increasing. Okay. So it's basically like you took the 4.3 stuff here and then added an extra prime to each thing. So if f double prime is greater than 0, then f prime of x is increasing. So that's kind of the idea of that relationship there. But if we look at what this really means here, the first derivative, f prime of x, again, that is giving us slopes of tangent lines. And so those slopes of tangent lines are increasing. So if we think about what that looks like, okay, I'm just going to write that in again. Tangent slopes are increasing. And so if we think about what an increasing slope might look like as we proceed along our function here, if we start out with a fairly small positive slope, let's just say we're looking at positives here, that would be, something like this maybe. That's slightly positive slope. Okay, and this is some little tangent line to our function. And now if we want f prime to increase, we need to increase that slope, and that would give us a slightly larger positive number, maybe a tangent slope or tangent line that looks like that. Okay. And then if we want f prime to increase again, we'll make it a steeper positive tangent line slope, and maybe even steeper, and even steeper. Okay, so those are a series of tangent lines with increasing slopes. Okay, I'm gonna make a little note here. They start kind of shallow and get steeper. Okay, this is when we're working with positive slopes in that case. And so if you imagine the function that would go with that, the function that would have those tangent lines with those increasing slopes, kind of sketch in a little function that would match those. Okay, so coming in tangent might look something like this green curve here. So that would be what the original function would look like if f prime of x is increasing and the second derivative is positive. Okay. Now, there is another kind of case here that we can look at for increasing slopes, increasing tangent line slopes. And that's what happens if we have a negative slope to begin with. Okay, so increasing tangent slopes, this is just a regular number line. There's 0. Okay, so we just looked at what happens with positive slopes. Okay, we started with a small positive slope and then we increased that number. So you got larger and larger positive numbers, larger and larger positive slopes. Okay, now if you had started with a negative number, okay, like maybe down here, if you had a negative slope initially, and we want to increase that tangent slope, okay, that number would become less and less negative, okay? So you start with a large negative number and then you move into these smaller negative numbers approaching 0 there. That's what happens if your slope is negative and increasing. So let's sketch out what that would look like in terms of a function. Okay. So you have a large negative tangent line slope to begin with, maybe something like that. And then when you increase f prime of x, increase the tangent slope, you're going to get a number that's still negative, but a little less negative. So a little less steep of a tangent line slope, maybe something like that. All right, and then you increase again, gets a little less steep. All right, and a little less steep until you would get zeros, and then maybe even if it kept increasing, your slopes could become positive, and then we would have the previous picture. Okay, so the function that would match up with these tangent lines would look something like this. Sketch in your curve, nice and tangent to each one of those lines, and that's what f of x might look like in that case with negative slopes. So large negative, when you increase, that makes your tangent line slope less steep. Okay, so both of these pictures are cases where the second derivative is positive. F prime of x is increasing. All right, and so we have a term for this. We say that in both of these cases, f of x, the original function, is something termed concave up or concave upwards. All right, concave upwards. Okay, so this is a good vocabulary term to know here, concave up. So this is starting to look at the idea of concavity, which is an attribute of a function. Just like you can find where a function is increasing or decreasing, you can find where a function is concave up or the other scenario that we're going to look at here next. So the other scenario, you might be able to guess where we're heading here, but we're going to look at cases where f double prime of x is less than 0. So we have a negative second derivative, and that is going to tell us that the first derivative is decreasing. Okay, so again, same idea there as you saw with the first derivative type of thing. Okay, if your first derivative was negative, your original function was decreasing. Now for this, if the second derivative is negative, your first derivative is decreasing. Okay, same relationship. All right. So let's sketch out what this might look like. All right, again, that f prime of x is looking at tangent slopes. And in this case, those tangent slopes are going to be decreasing. So let's start with looking at some positive slopes. Usually these are a little easier to picture what's going on. Okay. So, all right, if you have a positive slope and we are looking at an area of decrease. Sorry, my phone is ringing in the background of this. That's obnoxious. Okay, hopefully you guys didn't hear that. Anyway, if we're looking at an area where the tangent slopes are decreasing, we'll say we start with a fairly large positive slope. Okay, so make a pretty steep positive line there. And then we want that tangent slope to decrease. So let's make it a little less positive, a little less steep. Something like that, maybe. And a little less steep, keep decreasing. And then it gets pretty shallow there. Okay, so for the positives, we're gonna start steep, and then the slopes get shallower. Positive slopes. And so if you sketch in a function that matches up with those tangent lines, your function would come in something like this, just kind of touching each one of those tangent lines very lightly. Okay, something like that for your f of x. All right. And there is another scenario if we consider again what's happening with negative slopes. All right, so let's draw that guy as well. So in the case of your negative slopes, if the number is decreasing, that means you are already starting negative. And you are going to decrease that value, so that sends you moving in the greater negative direction. So your slopes here, your tangent line slopes, are going to become larger and larger negative numbers. So let's start ourselves out with a fairly small negative slope. Okay, nothing too steep here, just a little negative like that. And then we want that slope to decrease. So move it to a larger negative number. Okay. And a little more negative. And a little more negative. That's getting pretty steep at that point. So let's sketch in a curve that could fit with those negative slopes. It might look something like this. Let's come in nice and tangent. Okay, there we go. So your f of x might look something like this. Okay, so if you start with a small negative, then that is going to become more negative or more steep in that negative slope direction. Okay, so that's what's happening if f prime of x is decreasing and you're looking at negative slopes. So If you look at these two cases, they get a term as well, and you might be able to guess it here. The original function, the little bit sketched in orange there, f of x is called concave down. Okay, concave down, or you might hear concave downwards. Downwards. I tend to just say concave down personally, a little faster. But yeah, concave down, concave downwards, that's describing these type of shapes. So if you want a really fast and cheesy way to remember what's concave up, what's concave down, you can see what happens when you put the two pieces of those graphs together. In the case of our concave up here, all right, if you look at the negative shape of the graph, it does something like this, okay? And then if you combine that with the shape of the positive slopes, start shallow, get steeper, that does something like this. So concave up makes this kind of U shape in the graph. Now, it might only be one part of it or the other, like you might only have one half of it, or you might only have this other half of it, but either of those pieces are concave up shapes. Same type of thing with concave down here, okay? Your positive tangent line slopes that start steep and get shallower, that is going to be this type of shape. And then your other type with the negative slopes that become more negative, that looks something like this. Okay, so together they make kind of an upside down U type of shape. Okay, so that gives you one way to remember it. The U shape is for up. Up starts with the U. The graph makes a U type of shape, either one half or the other half or the whole thing. But then an even, I don't know, funnier way that I like to remember it is if you take that type of shape and now you put two little dots above it, you get a smiley face. Okay, so that's the concave up type. It's like upbeat, happy mood, smiley face. Then down here, if you take your concave down shape and put two little dots above it, you get frowny face. That guy's feeling down. So that is the concave down type of shape. Okay, so those little guys, smiley face, frowny face, are good ways to remember what the shapes of graphs look like when they're concave up or concave down.